So yeah, we talked about tables, and there's a bunch of different things you can do to tables, and it's all here. All this stuff that we talked about last time, if you want to look at this, it is in the code from class, and that might be a good thing to have open as we work through today. So that's, you can click on any lecture, but also right here, code from class. Boop, boop, boop. At least you'll get the old version. It won't be auto-updated, but the chapter 6 is what we worked on if you want to click there. And also the data that we were working with before is somewhere in this folder that you can download. All right, so just quick review. Through our data science library or module, we get access to this wonderful, wonderful table kind of function idea that creates a two-dimensional table inside of Python. All right, and everything has a row. Every piece of the table is made up of you got like labels, and then you have a bunch of rows, and there is an element. These are columns, right? There's a bunch of names in the name column. There's a bunch of ages in the age column, and the types, like it's a bunch of strs, right? Strings for names, ints for ages if they're whole numbers at least. There could be different things, and you can build up bigger tables by attaching to older ones, right? It's like you can start with the people table, and like you can attach a column. Here's the name. Here is the values in every piece of like for every element that's already there, for every piece, we'll make an array with all those things. So like you can attach a brand new column by giving values for every existing row. That's beautiful. And you can relabel stuff with .relabel, read in things. Num columns, num rows gives you how big your table is. Labels gives you what's there. And yeah, kind of the key things that we learned were you can get out a column. That gives you the array, so you can do math with it. And what else? You can select out from a larger table pieces that you want. Like I just want, and the order can potentially change. Like I want the flavor first, then price with tax second. I can get those things by selecting them. And indices work as well. Remember that indices are like starts at 0. That gives you the first thing. Index 1 is your second thing, which is a little confusing. Can't forget about that. So select, drop gets rid of stuff. Sort will sort by a column, by default ascending from smaller to bigger, but you can say descending equals true to do it in reverse. So just go and look at all these things. We'll get back to those. And then .where is like where we get a lot of power. We can test things. We can extract just the rows that we care about, like where the flavor is equal to chocolate. This one is shorthand for this one. Where Cohn's table, take all the values where the flavor rows, where the flavor column values are equal to chocolate. That's how you think about it. And there's a big long table from our slides last time, which you do have access to, with all those things that you can ask. And so yeah, with that, we tried it with Pokemon, and I just want to try it with some other stuff today, if you would like. So yeah, do those words all make sense and they're coming back to us? You ready to continue? All right, so I have 3 interesting data sets. 2 were made by other people, 1 was made by me from Wikipedia. But here is a very old data set containing different cereals that were around quite a while ago. All right, so sadly they don't have my favorite cereal, but it's interesting to see what used to be there. So let's look at the cereal data set. All right, it's here in our data folder. If you go to the code from class, it's in the data folder, and it's called cereal.csv, and you can download it. You click download, that little button right there. And what you want to do is, depending on how you're working, right, get into your version of Jupyter Lab or whatever, or go to this link, and then you drag it in, right? You'll drag it in, and then you'll read that table. And I'm going to try to not give you as much help as I did yesterday. I want you to try to read it in, try to get looking at that table in some way. I'll give you like a 5-minute head start to try that, maybe. But run that, and remember that if you work on the website like this, you can go and like drag it into this little files tab. The thing that you just downloaded, if I can, I guess it wasn't open. My downloads folder, you just drag it right there, and now it's there that you can read it. All right. So yeah, the cereal file looks like this. Here's what's in it, at least. It's a bunch of old cereal values. So there's a name column, there's a manufacturer column, a type, a calories, amount of protein, and like the suggested daily amount of the cereal, amount of fat, sodium, fiber, carbs, sugar. So like stuff that you would care about, all the way to let's see, how much you should have of it, people's ratings of it, what shelf it was on. So yeah, let's look at this. This is here are all the columns. So manufacturer was like all of these different manufacturers. And I haven't heard of some of these, like they were around in the 90s and maybe they got rid of, like, doesn't that one only make like cat food now or something? So that's interesting. Different kinds of, like, was it a cold cereal? Was it a hot cereal? And let's see, vitamins is like how much vitamins they added, like not how much was actually in the cereal, which is kind of interesting. And yeah, shelf was what shelf it was on from the floor. So like shelf one was it was the lowest shelf to the floor. Shelf two was the cereal was found. Somebody just went to a supermarket and looked at this stuff because it varies by supermarket, right? Then the second was like it was on the next shelf, and then three was on like the tallest shelf. So yeah, these are what the columns hold, and I'll come back to this slide while you work. But my question for you is to kind of do what we did last time. So I'd like you to read this data into a table, please, and take a look at what's there. I'll go back to this so that you can see it and like what's happening. But I'd like you to, as a group, get with the people sitting next to you, say hello, talk about your weekends, and then try to answer as best as you can what you think is going on here. Like what do we think we could ask? Like what are some good questions about the data that we see? Okay, and yeah, we'll take some of your ideas and we'll work on them. But I do want to give you a little bit of a head start so that you can at least like get the data, get it read in, maybe try a few things to like maybe decide which of the questions that you have are the most important. But I'd like to hear them. Please, if one of you could go to the written ice page, we can write them down again. I think that's a good setup. But I think, once I clear it all out for us, I think that is all that I wanted to say. So does the task make sense? So I just want you to practice stuff from last time, remember how it all works, and then we'll come back and we'll work on them together after a bit of a head start. Okay? So yeah, here is the description of those columns, and remember it's serial.csv in the data folder in our code from class. So please try that and take a look. Click on my code from the chapter 6 code from last time, and it'll show you like what I did if you forgot how to read it into a table. But try it. I have some questions as well that I thought of ahead of time. Question, yeah.
What does type stand for?
This one?
Oh.
So was it a cold cereal or was it a hot cereal? It's like oatmeal, I guess, would be a hot cereal in theory. usually. Yeah, some of these cereals I've never heard of. I was alive, but I was not conscious back then. Another minute or so to think about some stuff, maybe try it, but we'll take a look at your ideas and go from there after that. We'll see what we can answer. Because we can answer a lot of questions with our current knowledge. Can't make the computer draw a graph yet. That's next chapter. But like we can draw it ourselves.
Do you know where the nearest bathroom is?
I would say around the corner. Go that way and just turn left. It'll be very, very quick after you turn left. I think it's this. Yeah. Alright, that was my timer. Does that make enough sense? Is the question now. What are our thoughts? Any questions came up as we were investigating? Let's see what I remember to press submit on your questions that you came up if you can, but I have some in the meantime. Or if you just want to shout them out, I'm interested in knowing. What do you think? Like, what are your questions that you came up with? Like, what could we ask about cereals that like you can't just read off the table? Or it would be very, very difficult to just read off the table. So yeah, try to get them in as you were discussing, but we can start with some questions that I was wondering in the meantime. So here are some things that I thought about while I was looking at this data set. Like, you guys heard that some supermarkets, I don't know, the bad ones maybe, they like to put the bad for you cereals on the lower shelves because like you're a parent, you're bringing your toddler, they're walking around, that's what they can see and like nag you to like, please buy that for me, mom, something like that. So I feel like that could be something we could investigate. Let's try that. So I'm going to read this table in. I need the data science library, and it's like every time I restart this, it's not loaded, so I gotta press it again to make sure it's all loaded and I have access to table stuff. And so it's in there now. Now I could scroll down, and I don't know how I want to separate this. I'll just use, I don't know, just use a long line. Because this is still chapter 6, but it's like the next day of chapter 6. So, okay, I would like to read into a table, table.read underscore table, right? My file is, well, here's chapter 6, and I got a data folder, and that's what has the serial.csv in it, so it's got to go in the data folder / serial.csv, and you can press tab, by the way, and it will like autocomplete stuff if you just start typing a little bit, which is really nice. So there's that. And I want to save, because this creates the table. I want to use it for more than just this one cell. So I want to save it in something. I'll just call it the same name kind of as the file. Serial equals that. And then I like to just like have it be printed out at the end, because like if you put it on a line by itself, it'll print it out. So cool. I don't know what -1 potassium means. Probably just like they couldn't find the value or wasn't listed on the thing. That would make the most sense to me. Does it say that? Yeah, so like sometimes when you're working with data, there might just be values that you don't have for certain rows, which is interesting to think about. So, okay, so there's a bunch of these guys, and you can look at the whole thing, probably easier to just like scroll through the CSV file. But you can look at pieces with the dot show. Like this one right now, if you just say serial, it shows you the first 10, but like if you want to see the first 15, like show 15 of them. I want to see more. I don't know. And so that's what's going on there. And you can see like the rows, the columns, and the labels. So, okay, if I have this question I want to ask, sugary cereals, are they on the shelf that I think they're on? Which columns should I use in my investigation, do you think? Which ones am I going to have to compare to things and like pick out? Which ones are important?
Shelf.
Definitely shelf, right? Shelf, and I'll probably want the name. Like I want to know which one it was, right? So shelf and name. What else? Yeah, I think those are probably the key ones that I need, the only ones I need, because I want to check like, all right, shelf 1, right? That's the one closest to the floor. Shelf 1 is closest to floor. So let me pick out all of the cereals on shelf 1 and look at how much sugar they have. Maybe I'll take the average of that. Does that make sense? And I'll do the same for 2 and for 3. So I think that's probably the way I'll deal with this. So I don't know. Shelves. Question. I don't know the best way to deal with this. I'll just say shelves. So I want to select out from cereal all the things I care about. I want to select the column for the name. I care about seeing the name eventually in my answer. I want the sugars and the shelf, but maybe shelf should come first. I don't know. You can reorder it as you select things out. Shelf and then sugars. What's that in, by the way? Is it just it's grams of sugar? Okay. So that's shelves. And so that's an easier table for me to work with that has just the key things that I care about. So that's pretty nice. And all right, let's select out, or not select, let's, I guess, use where to get the cereals that are only on shelf 1 right now. So shelf 1, like I'll make a variable for that table because it's always going to give me back a table, right? Shelf 1 equals, we'll take all the things in shelves. I hope that's how you pluralize shelves. Dot where, right? I want to select out just the rows of shelves where the shelf number is equal to 1. So the shorthand is you can just type 1 there, but the longhand is you could say where the values of shelf are dot equal to 1. All right, so let me just give you a lot of practice with that. So I'll just say that where the shelf values are equal to the number 1. And so those are all the things on shelf 1. Here they all are. And there's apparently 20 exactly, because there's 10 by default that get shown to you, and it's like 10 rows of minute. And you can always ask, like, all right, how many were there? Let's say num rows, right? How many were there? There's 20 out of how many? 672, I guess, cereals total. So that's a decent amount on shelf 1. And now I want to take and figure out, like, on average, maybe that would probably be a good thing to ask, right? On average, how many grams of sugar are in these things? And honestly, a lot of these look slightly healthy, like Frosted Flakes sticks out, but not horrible. So maybe this was a good supermarket. This was before that became a popular thing to do. I don't know. So, okay, that's everything in shelf 1. I can say shelf 1. I can select out, or I can get the column for sugars, right? If you say dot column and say what the name of it is, or the index. So dot column sugars gives me all the values in the columns. In the sugars column as an array, so I can do math with it. Or I could say dot column the index of the sugars column. And can anybody tell me which one that is? Yeah, so remember they start at 0. So the name is 0, shelf is 1, and sugars is 2. So I also could have said dot column 2 and got the exact same thing, but I kind of prefer the name here, sugars. you come back and like if you come back after a week and you read that, if it said dot column 2 versus dot column sugars, it's probably makes more sense to see the word sugar there, I would say. So yeah, there's that. And what you can do to an array, one thing that arrays let you do is you can say dot mean, which gives you the average. I wonder if you can also say dot average. Sometimes you can do both. No, that one doesn't exist, sorry. Dot mean, that one does. So that's one thing you can do to arrays. If you go back to the sequences slides, like that is apparently the average amount of sugar in all the cereals on shelf 1. Does that make sense? How we got there? And if we want to know, like, what's that?
Is that in grams?
In grams, yes. That was apparently the amount. Where was it? Grams of sugars. Cool. So we have that now. We have that knowledge. And we kind of want to compare, right? Because like just getting this by itself is kind of not very useful. So let's do the same for the other shelves. I can make shelf 2 and shelf 3, or I could do it very quickly, probably all in one line, but we'll do it slowly together. So let's get all the things in this table where the shelf is 2. So not 1, but 2 now. So if I just say that, that gives me this table, everything with shelf 2. And honestly, maybe the toddlers are looking at shelf 2. I see a lot more sugary things. So maybe shelf 1 was too low. I don't know. So there's that one. And now this is just the table itself, right? I can attach more things to this question. Like, all right, that's that table. I can now pick out immediately the sugars column of that table. I can say, all right, take all that, dot column sugars. Does that make sense? Like I can do that. Sugars, boop. And so there's that. And I can do the same thing that I did like in this 2-step process up here in just 1 step. All right, now there's the column, there's an array, and I know that every array I can ask for the mean, which is just the average, another word for it. And it looks like shelf 2 is worse. So maybe that one's the one at the eye level. I don't know. Or maybe they think that the kids are going to be sitting in the cart, and so they're a bit higher up or something. I don't know. But it looks like shelf 2 is the unhealthy shelf so far. Let's see what happens for shelf 3. And that's a very quick question to ask. It's like I just changed that to 3, and it goes back down again. So I think, yeah, maybe it is shelf 2 then. That's the bad one. Like that's the level. Because like if shelf 1's on the floor, maybe your head's not down, but like that's eye level maybe for a toddler. I don't know. Dad, can I get this? So yeah, I don't know. That answers our question, right? I think that's pretty fun. So yeah, any questions about how I came up with this and how I thought about finding these answers? It's like that's your job as a data scientist. I hope that's interesting to you. You're in the right place if it is. So yeah, that's one of my questions. Did you guys write down any brave people? Nice, yeah, cool. Some of these I think I had myself as well. Are cold cereals better for you? Which cereal, if any, has equal amounts of sugar and fiber? Yeah, these are great questions. So, okay, we can ask that question again by maybe taking the average, like looking at the cold cereals, looking at maybe how many vitamins they have, percent vitamins, or I don't know, maybe we care about fiber, or maybe we care about like having a lot of protein. Like what constitutes better for us, do we think? Like what should we measure? Because that's tough, right? Some things that you can do, and we'll see this later, is you can come up with one number that kind of combines a lot of these ideas. Like maybe you can multiply the calories by the protein by the fat. You can come up with one big number in a weird way that kind of is higher when it's healthier and lower when it's not healthier. Because some of these numbers mean it's like if it's higher it's healthy, some of them if it's lower it's healthy, stuff like that. So there's ways to come up with one single number that kind of combines a lot of stuff, but we're not ready for that yet. So maybe let's care about, I don't know, maybe how about protein? I don't know. People they need a lot of protein, right? Or fiber. I don't know. That usually means it's healthy, right? When there's fiber. So maybe we can try both of those. I don't know. That could work. That would work for me. So let's try it. So, okay. The question is, are cold cereals better for us? I have this cereals table. Did I just call it cereal? Yeah. I have the cereal table, and I would like to get just the cereals that are cold. And so that is, where is that? Oh, it's just type. C means cold, I assume, and H means hot. All right. So I want to pick out the cereals that are hot or cold, but like this is a lot of data at once. Again, you can select out just the stuff you care about, like the name, the type, And did we care about protein and fiber maybe? If that means healthy. So yeah, those are those. And so let's do the cold cereals. Like, I don't know. Cold versus hot equals, like, there's my starter table. And then how do I want to deal with this? I want to say, all right, let's get just the cold cereals, cold versus hot. Or I guess we're looking at a lot of cold cereals. Let's get the hot cereals first. Why not? Cold versus hot, where the type column values are equal to H, I assume is hot, right? Or you can also say where they're not equal to C. Are there only 3, really? That's not a good sample. I think there are only 3. Wow. Okay. Maybe that's not the best data set, but all right, we got 3 hot cereals. And I guess we can kind of just look at them, protein versus fat. So the average amount of like protein, for example, we can say, all right, dot, let's get the column for protein. Boop. It's that, and we can take the average. Cool, so it's apparently the average amount of protein in a hot cereal of the ones that are here, which is not many, so maybe it's not a good sample, is 4 grams of protein, I assume. And you can do the same for fiber, like how much fiber? That much. Something like that. I don't know. But does everybody understand how this line is asking kind of a big question? Like, all right, it's asking this question. What is the average amount of protein in the hot cereals in the data set? You kind of see how I selected it out and like got the things I needed. Cool. So we can do the same for the fiber, and let's do the same for the others as well. So there's fiber, less here, and so that's the hot cereals. And so to easily check the cold cereals, it's just one change, right? If I want the average amount of protein in the cold cereals, it's like where it's equal to C. Or you can do the shorthand, it's like where the type, just put C there. By default, it goes to the equal to. Sorry, what's the average amount of protein in a cold cereal? Oh wait, I have to rerun this. It is less. Makes sense, maybe like oatmeal's bringing up the hot cereals. A lot of protein maybe. And then same for fiber. Looks like there's more fiber in a lot of the cold cereals, so like, I don't know, all the different kinds of Raisin Bran are probably bringing that number up or something. But like, that's a cool question to ask, I think. Are there any questions about how we answered it? Because this is the kind of like thought process you have to go through, and I hope that I'm saying enough out loud to have it make sense. Cool. Nice. So let's see here. Yeah, let's do a couple more, because we have a few more data sets to get to today. Which cereals have sugars greater than 10? And you guys can totally be trying this. You can all see these questions too, right? You can try your own. I highly encourage it. Which cereals have sugars greater than 10, and what is each cereal's rating from highest to lowest? Nice. So these are great questions. On protein. Oh yeah, we can ask a bunch of questions. What is the amount of protein with cereals that have less than 100 carbs, like the healthier ones in terms of carbs? So that's cool. Let's figure this out. Which cereals have sugars greater than 10, and what is their rating from highest to lowest? So like we can do, I don't know if that's a combined question or not, but we could treat it as one. We got this guy. And if you want to be just lazy, you don't have to make your own separate table by selecting things out. Like you can use this one if you need to, if you understand it well enough. Like to quickly ask, like, which cereals have sugars greater than 10? It's like cereal dot where the sugars values, that one is apparently plural, are, and it's, what is it? Is it above? I still need to memorize all these. So it's where the values are above 10 or above or equal to 10, depending on how you think about it. Greater than, equal to, or just greater than? So greater than is what we say here. So I'll say above 10. Above the number 10. And remember that 10 is a number. And so I don't put it between quotes or anything. I don't want to like treat it like text. 10, the digits. I'd rather have it be the numbers. So there's that. So this will give me all the cereals where the sugars are above 10 grams, I guess. So that's all these guys. Look at the sugars column. And I don't know. We can see, how about we ask the question, like, we could look at the ratings as well. It's like, sort by the ratings now of all these, just the ones above 10. Sort by rating. And we probably care about the ones that are highest first, so we say descending equals true. It's like the highest cereal with the amount with sugars above 10 is fruitful bran. So I guess the fruits add in the sugar. It's surprising to me that Raisin Bran has so much sugar in it, but I guess it's the raisins, right? It's interesting to think about. Yeah, that would be a great thing to add to this data set. But we don't get it. Is there a way to extract it now? Interesting. So yeah, those are great numbers. You can also like get another cool question to maybe ask of like, all right, where the sugars are above 10 versus not above 10, what's the average rating? Like, give me, these are all the ones where the sugar's above 10. Give me the column for rating and give me the average. And then do the same for all the cereals where the sugars are not above 10. Say not above. You could also, what's the opposite of above? It's less than or equal to, so like below or equal to would also be in one. But you can also say not underscore to get that. And it looks like, actually the cereals were I don't know where they got these ratings, but apparently the ones with fewer amounts of sugar is like smaller amount of sugar. They're rated higher on average. Crazy. I guess there was a big health food craze in the 90s. Kind of makes sense, maybe. I'm not sure. Interesting. But yeah, these are great questions. But also, like, again, before I move on, like, do we see how I came up with these, like, these long strings of, like, let's select out these things, get this stuff, do this to it? Like, does that all make sense? Because, like, that's what I want to teach you. The cool facts we discover are just side effects. All right. Let's see. We probably have time we can do both. So let's do this one and this one. Does the amount of protein correlate with the consumer rating? Yeah, we could do the same kind of question, I think. That would be a very similar question to this one. So the amount of protein, does it correlate with the consumer rating? So let's like take what are some values of protein? 3, 4, 1. Let's figure out like what's the average amount of protein in all the cereals. Cereal dot give me the column for protein. So average is a very important thing that we're going to care a lot about. So apparently the average is about 2.5. So let's have that be our split point. It's like let's look at all the cereals where the protein's less than that and the cereals where the protein's greater than that and see how their rating compares. That could be how we phrase that question. We can also find this probably a graph would be the better way to look at this, but we'll come back to that question. Remember this question for when we look at the cereals data set when we learn how to draw graphs. That'd be great. All right. Yeah, this data science library lets you make pretty pictures. We did that on the first day. Oh. That's a huge thing that we care about. That'll be next chapter, though. Feel free to read ahead. Yeah, so let's do that. I think that would make sense. So, like, let's get all the cereal. And let's get the ones where the protein values, remember this is what cereal looks like. Let's get all the cereals where the protein values are less than this kind of average of like 2.5, where the protein values are below 2.5, I guess, let's say. So that's the cereal with not a lot of protein. And let's see what their average rating is. So again, we can like select out from that the column called rating and get the average of just those. So this is the average rating of cereals where the protein amount is less than 2.5 grams. Does that make sense? You can kind of read it backwards. And you can do the same for the opposite one. So the ones where it's, I guess you could say not below if you really wanted to, but it makes more sense for me to think of like, what's the opposite of less than? Below is less than. The opposite of less than is greater than or equal to, right? So it would be above or equal to in the lingo of the .where conditions. So above or equal to, they like to spell it out. And they really like their words are above or equal to 2.5. And it looks like when there's more protein, there's a higher rating. Interesting. I'd love to see the same with like fat, because like everybody hated fat in the 90s, I remember. They were all wrong though. So yeah, does this make sense how we asked that question and found the answer? You could phrase this in different ways. It would make more sense probably to draw a graph. We'll get there. But like you could cut it off in like little chunks. Like, all right, between like 0 and 1, 1 and 2, 2 and 3. Like you can go in finer grains and draw a graph on paper if you need to, but like this is a good cutoff. I would say the average is usually a good cutoff a lot of the time. So there's that. And yeah, the last one, which cereal has the most nutritional value or vitamin density? I think it only goes up to 100. But you can, that's actually a good idea though, because it's like, if we think about it, so vitamins goes up to 100, so like how much of the percent daily value of vitamins are they fortifying this cereal with? But you could probably come up with a cool number like, where is it, vitamins. So sometimes it's like 25%, 100%. We could do like vitamins per, like, per volume, per weight, or per volume. Does that make sense? Like, because cups is the amount of the serving size. Like, how packed then with vitamins is this serving of cereal? Like, so if you wanted to eat the smallest amount of cereal right now, you don't have a very, like your stomach is pretty full, but you want a good amount of vitamins. Like, what's the one I should look for right now? Like that kind of question. I think we can ask that by taking the cups amount and then also the vitamins amount and kind of like dividing them. Does that make sense? Like vitamins per cup. Oh, is there a weight column as well? Oh, that would, yeah. I guess do we want volume or do we want weight? Vitamins by volume or vitamins by weight? We could do both. Let's do both. So yeah, weight in ounces of one serving versus number of cups in one serving. So volume versus weight. Age-old question. Cereal. So all right. Again, let me try and break it down how I'm going to think about this. So I want to extract the, I don't know. For each cereal, I want to extract the column called vitamins for sure, right? So that's an array of all the different vitamins, and I want to divide that, right? Like, so for the first one, it's got 25% vitamins. I want to divide that by, let's start with the weight, by like that much. Sometimes it's that much. Like that's how many ounces should be in one serving, and that will give me vitamins per gram, or vitamins per ounce. Okay, and you can do this by picking out that column too. Like give me the cereal column called weight, and you can, as long as they're two evenly equal sized arrays, it'll just like pick out each piece of them and divide each by each. So that is a big long vitamins per weight array. Does that kind of make sense? So for each cereal, it's going in order, and what we can do is we could add it back into cereal. All right. So this is a little weird. So this is like vitamins by weight. Is that? And we can do the same thing for vitamins by cups. We just divide by cups instead. So all those values like that. And I can add these pieces back into the cereal table. So like I can take cereal dot, like let's select just out the name and the vitamins and the weight and the cups. So like those are the things I'm using. And then I can also add in these new columns, right? These are just as many as there are rows, because it's doing the crunch of the numbers for each piece. So I can say dot with columns, and I can give, all right, give vitamins by weight, like whatever you want this to be called. Oh, I'm sorry, not vitamins by weight. This one's vitamins by cups. Let me rerun that cell so it doesn't mess it up. So vitamins by weight is that one. So that's one new column. And then you just keep on adding the ones you want. The next column I care about is vitamins by cups. Cool. And now you can start sorting this, right? This could be like, this could be the vitamins table now. But I took pieces of the original table, like these pieces, and I added in our new stuff. Isn't that cool? And then you can start sorting. Be like vitamins table dot sort by vitamins by weight. And probably you want it descending, right? Descending equals true. Oops, what did I do wrong? Oh, I added another quote that I didn't need to. So it looks like, interesting. A lot of the time it's the unhealthy ones that they add a lot of vitamins to. So apparently whatever that was, just right crunchy nuggets at the top. It's breaking a lot of ties though. These are all the same. Like Raisin Bran, total corn, total added a bunch of total amounts of vitamins, I guess. That's what the brand did. So that's for vitamins by weight. And it looks like vitamins by cups could have been bigger. So let's try that too. So like, let's see, this is vitamins by cups now. Descending equals true. And it looks like you get the most amount of vitamins by volume with the fruit and nut. It's not as heavy though, because I guess the fruits are light because they're dehydrated or something. I'm not sure. But like that's a question. And we found an answer. Does it make sense how we came about this? All these new exciting pieces of information. So I like this. Yeah, I think that's what I wanted to say about cereal. Are we ready to try a different one? I think that's fun. So yeah, I have other questions, and honestly, we asked a few of those. So that's pretty cool. The next data set I have is there's a data set that somebody made of everybody who was on board the Titanic when it crashed. So I got that one for us. What's that?
The real man?
The real Titanic. The real Titanic. And so here it is. It's titanic.csv. So please go get that and drag it in. It's in our code from class, the data folder. And it's just called titanic.csv. And like download that, add it into where you need it to go. But inside of the Titanic data set, there are these labels for these columns. So you have, in addition to people's like names and stuff, which look kind of cool, old-timey names, you have some of these are not very useful to us, like the ID of the passenger. That's not interesting to us right now. But some of these are, like, all right, male versus female. What was the age of this person at the time when, like, the Titanic crashed? There's that. Let me look at it in the Jupyter place, so it's a little bit bigger, maybe. Beep. So here it's not honestly that much bigger. Some of these ages were known pretty well. Like some of these have 0.5s in them. Like this dude was 22 and a half. So there's that. What else? We've got number of siblings and or spouses aboard. So like were they there alone or were they there with a wife, a husband? And then same with children, like number of parents / children aboard. Like was this person either with their parents or was this parent with one or more children? How much money they paid in pounds for their ticket, which probably correlates very well with which class their class of like room on the ship they were in. So P class stands for passenger class, like first class, second class, third class. Which cabin they were in on the ship, which if we had a map, I'm sure that would be helpful. But some of these are unknown, so they're blank. And like where did they get on the Titanic? Apparently, like there are a few options where you could have gotten on it. But those are the labels. And I feel like there are some great questions that we could ask about this, yeah? So I'd like us to try the same thing, please. If you are on the Written Ice page, please refresh it so that I can delete stuff. Because I'm going to get rid of our old posts. So it's like refresh the page so it's back to normal and you see blankness again. But with this, I'd like you to try the same thing, all right? So I'll go back to this slide after I like explain what I want. So like, please get the table, get the data in table form, come up with some ideas again, like what could we ask, and then like I want you to try them yourself. All right, I'll look and see like after some time like what you thought about and maybe give you some pointers. But I want you to try like to answer these questions that you come up with on your own, because that should feel very validating, like you're learning something, right? And then I'll help as needed, and like I'll pick out some and try them too. Okay, so I think that's what I wanted to say. Are there questions about the task? It's pretty much the same task again. Yeah, but I want you to try first. So here's the columns, and I'll give you a few minutes to like discuss, write down your ideas so that you remember them and so that I can see them, and then play around. I think it will be fun. And just quickly, what is this? Oh, nice. Those are my ideas. But yeah, I want you to try yours. So it's Titanic.csv. You just drag it in. And then come with some interesting questions. And of course, surviving is probably going to come up a lot in whatever question you have. Like, did this person survive? They make it off the Titanic, or did they not? I think most of the questions in my mind revolve around that compared to other ideas. Yeah, see if you can ask the questions that you come up with in your mind. Few more seconds of a head start, then I'm interested in seeing what this is. When you find numbers or ideas or values. Got tables at least. We're doing stuff. All right. What were our thoughts? What did we come up with? And did we get it? Average fare, I like that. Nice. So, were some of us able to answer our questions and find a value, or like at least a form to look at it and like answer things? I hope so. Or did we have any questions that came up as we were trying to do it ourselves? Did it make enough sense, like the process, even if maybe we didn't have enough time?
We were thinking of like being out for like the most popular names on the
Ah.
so if they're all grouped together, kind of
That would be more advanced Python stuff that we don't have access to yet, I think. But that's a cool idea, like all these different names. You'd want to split it by probably first name, last name, right? And so there's ways to do that. Did I show that to us? I can't remember. If you have a string, like there is a way. Like let me read it into a table real quick. So table dot read table. What do I want? Table read table data slash Titanic. I'll call this Titanic. Boop. Here are all these, and you can get the name column. It'd be like Titanic dot column name, and then you got all these different values. Oops, what's the problem here? Oh, sorry, it's capital name. And you got all these values, which is a little disgusting, but we don't know how to like go through them yet, sadly. You can get like one of them, like give me the one at index 25. I don't know. So that's the 26th one. And there is a way to take a string, like this is a string at this point, it's a stir. There's something on strings that's called split. You can split by the comma space. And you got two pieces, and like one's the first name, one's the last name. Then you have to do some more pre-processing. But that's one way to get like the last names or something. There's ways to get in there, but that's going to be, I think, chapter 9 or something. So look forward to that. There's ways to process just like the strings inside of a given column, which is cool to think about. But yeah, that's a good question to wonder about, because that is probably something you care about doing one day. So come back to this question. We'll ask it again maybe when we get to chapter 9 or so, when we learn about it's a concept called loops that we really need right now. Yeah. Any other questions that came up as we were trying stuff? Did it make enough sense? Yeah.
I was trying to calculate the average age of survivors.
Nice.
I have a number for the age of man. I don't know
Ah.
if it matters how many times it shows up or if it just shows up once.
That is a great question. So Nan means not a number. That's what that stands for. And so it looks like there probably then wasn't a value for some of these people, like they didn't know their age. So let's look at that. That's a great thing to notice and to wonder about where. So it's age here. Let's look at the age column. So Titanic, give me everybody in the age column. Column age. Is it capital or lowercase age? They're doing capitals in this data set. Capital age. And it looks like some of them we don't know. And so you can say that Nan is actually a float. You can say Nan. And it's like, oh, where is it? Is it capital? I forget how to say it in Python. Let me quickly do it. Nan. Oh, it's somewhere. You have to say float Nan. It's disgusting. But somehow you can get it. Get that value. Let's see. And how does that compare to things? Like, is Nan greater than 0? No. Is it less than 0? I think it just doesn't compare at all to anything. So I think that's probably the answer. Yeah, it messes everything up. But what we can do to fix it is, because it can't compare to any other numbers, we can just like make sure nobody, like, let's do math on only the ones that we knew about, because then we can actually get a real result. So yeah, let's do that idea. Let me show you how. That's a great question, because sometimes you're going to be working with a data set one day and like you don't have this person's birthday, you don't have how old they are, but still you want to do math, you want to work on what you do have. So let's make Titanic. Let's make a new table. Titanic, no Nan for the H, which is equal to, start with Titanic, and let's get the age values, where the H values are, I guess, above 0. It's a weird question to ask, but the above 0-ness will filter out all the Nans, because Nan is not above 0. Nan is not a number at all, which is kind of cool to think about. So I think that would fix it. And that would give us fewer rows, but that's okay. These are now good values for at least age. All right. And now we can do what you wanted. Now we can select out, you said survivors versus non-survivors? Yeah, that's a great question. It's like, all right, now that I have this where I can actually do math and not get not a number as a result, let's do dot, I don't know, where the survived value, if I can spell survived, where the survived value was, let's do the survivors first. So 1 means they survived, 0 means they didn't survive, true and false. So those are the ones that survived, and let's get their average age. Here are all the survivors, here are their ages. Let's get their average age. Dot, give me the column for age, because then I can do, what's it called? Then I can do array stuff and get the average age. Dot mean. That's about a little over 30 for the survivors. And the non-survivors, ooh, there's no real difference. That's very interesting. I didn't know that. That's a cool question to ask. It looks like it didn't matter the age of the survivors, just like probably where they were on the ship or something at the time. That's a great, cool thing that we know now. That's so nice. So, yeah. Are there any questions about that question? Does it make enough sense? That's so cool. Any other questions that came up as we were trying things that just didn't work right that I could talk about? Because yeah, this is just fun to explore, and like once we learn more stuff, we can keep coming back to these data sets. I'm very excited. So today is just like, let's remember all the stuff we know and have fun with it. So let's see. Let's go to some of your questions. What's the average fare of first-class passengers? Or is there a correlation between fare and survival? Yeah, we can do this. Dun, dun, dun. Let's do some of those. What did I want to say? Was there anything? So yeah, we'll do fare and survival. So Titanic. Are there fare values that are Nans as well, though? That's another question. Let's look at the fare values. Do we have a number for all of those is the question. Titanic, give me the column for fare. It looks like we always have a fare. One person got in for free, good for them. There is a Nan. There is a Nan, darn it. All right, so we have to do the same game for fare if we want to get like the values back properly. We have to get rid of anything that could be, like, get rid of all the values that did not exist. So Nan. So, okay. Titanic. We can do the same thing. No Nan for fare. Where fare is above 0. Somehow that'll just get rid of it. That's fine, which is great. And then, all right, now we can do fare stuff. So average fare of first-class passengers. So, all right, take this table. Now we have all the like actual values for fare always in pounds, British pounds. And we want to go through it and get, let's see, Well, we have to get just the first class passengers, right? So let's get just those guys. So where it's P class like that is equal to, so like where the P class values are equal to 1 for first class, or you can just say 1. So where those values are 1, there's these guys. Some of them survived, some of them didn't survive. We can get their fare now. We know we can do math on that. So let's select out the column called fare, and then I can compute the average of that. Does that make sense? And you can do the same for the other classes. Like, all right, first class probably is a lot more expensive than second class. Yes, significantly. And then third class, I assume, is the cheapest of them all. And yeah, that kind of makes a good deal of sense. Like, second class is twice as expensive as third class, and first class is about 4 times as expensive as second class. Makes sense. Cool. Any questions about how I found all this? Does it make sense how I'm thinking about it and like typing the right stuff? Because that's what I want to get in your brains. That's pretty cool. Yeah, let's do another correlation with fare and survival. That's another cool one. So that would still be the one with get rid of all the nans for fare. Again, let me say, just write it down. So nan, that means not a number. That means we didn't have a value for that piece, and it was supposed to be a number. For like strings, when there's a string that we don't have, it's just like there's a blank for a name. It's just the empty string. That's the thing. It's not nan at that point because it doesn't have to be a number. All right, so starting with this again, let's ask the question, correlation with fare and survival. All right, so again, a graph would probably show this better, but we can section it off. We can be like, all right, let's get all the people who paid like above, what's the average fare? Let's see here. Give me the column for fare for everybody of every class. Give me that average. So the average fare is about 35 pounds-ish, but that kind of separates first and second, doesn't it? A lot. How do we want to do this? This is the age-old question now. Fare and survival. So let's do like above, I don't know, 20. So it's kind of like in the middle, right, of second class. So it's a little bit lower than the actual mean here, but maybe like the first class, very expensive rich people are dragging that up. So let's like do about 20. I think that would make sense. So let's go and get, so again, here's the actual table. Let's go and get all the people who paid more than 20 pounds for their ticket. So that's where the fare is, where the fare values are above 20 pounds. So that's all these people with all these values. Some of them are like high rollers. Some of them are just like second class people there. And let's see. Then I want the average value of, or I want their percentage of the survivors, right? I want percentage of survivors, which is interesting to think about because the survived value is either 0 or 1, right? It's either a 0 or 1. So I can actually very easily get a percentage of how many people survive by just taking the average of the survived column. Does that make sense? Like it's a bunch of zeros plus a bunch of ones. And so once it divides by the total, that gives me the percentage, like how many ones were there. That's kind of cool. So just taking that average. It's like, give me the column for survived. That's just a bunch of zeros and ones. If I take the average of that, that gives me the percentage, like how many ones were there. It just adds up all the ones and zeros and divides by the total. That's the percentage of survivors. That's kind of neat. So almost 50% survived if they paid above 20 pounds. Does that make sense how I asked that question? That's pretty cool. And let's say if it wasn't above 20, it's the opposite, right? It looked like if you paid less, you were a lot less likely to survive. Cool. Now we know. Which makes sense. I don't know if you guys watched the movie. I don't know very much about the Titanic, but I did watch that one movie. It's like, I think when they hit the iceberg, like people were trapped in the lower decks because like that's where the cheaper tickets like had you stay, which is unfortunate. but I think that could be the reason for this. But yeah, that's a great question. Any other questions about how I found this, the answers, anything like that? And just shout out things if you think of them. But yeah, this is fun for me. Let's see, what else? What else do I want to say? Yeah, parent survival, number of female survivors versus male survivors within a range. I like this. I like that question. I think I'd like to go to that one. I think that would be a good one to end on. Nice. But these are great ideas, and I encourage you to try them yourself. And I can help you. Let's see here. Okay. Female survivors versus male survivors. Now let's see, do we know the genders of every Titanic passenger? Is there... Yeah, that's in the sex column, but are there any blanks? Because that would throw things off as well. Oh, actually not, because we can select out. Just give me the male ones, give me the female ones. So those are only two options here. And it looks like they're all filled in, so we're gonna get answers. Okay. That's perfect. Let's do a more general question first. Let's just do female versus male survivors out of every age range, and then we'll split it down because that's going to be two wheres at once, and I like that. I like that a lot. So I'm going to show that to you. We'll work up to it. So here's the whole Titanic data set, and we can get just the men and just the women, right? So Titanic dot where the sex column values are equal to male. That will just give me all the men on the Titanic. And then I can easily ask the question, like, how many of them survived? So I'll get out the column for survived, which is a bunch of ones and zeros. And I can get the average. Oh, what is it saying here? None of them survived? That doesn't make sense. What happened here? Or they didn't write it down. Is that actually true? I'm sure there were male survivors. I guess there's something about this data set. Maybe all the men who were survivors did not write their name down because they were embarrassed. But it looks like at least in this data set, maybe that is true. Weird. I don't think it was true in real life. So there must be some pieces missing here. But weird. Now we know. I got this from like a normal place. I wonder what they're saying about it. We can search for it real quick. Titanic data set.
20% of men survived. 75% women, 52 children.
So there was a decent, like, non-zero, right?
Mm-hmm.
Interesting. So this is where I got this data set from. Dun dun dun. Survived, didn't survive. But legitimately, you mean where there's a bunch of ones and sort ascending, I guess. Show me the male survivors. That's so weird. Apparently in this particular data set, we have no information about the male. Wait, there's one. Right? Maybe
the table we have is incomplete.
Yeah, I think maybe I got this from a different place then. So I'll download this one. I'll give this one to you. Download it as a zip file, sure. Oh man. I will sign in with Google then. Oh, cool. Give it to me. Let's use this one. I'll give this to you after it's over, but I want to know now. This is weird. Oh, but this is an Excel file? That's disgusting. Yeah. Okay, no, it's a CSV file, but was declared wrong. Oh, this is what happens when you have to do data science sometimes. It's like... But I'll update ours to this. Excel. It looks like... Let's filter. This one. Do we have men who survive? Yeah, this one has men who survive. Okay, cool. That's better. But also they've named things slightly different. No, we still have P class and all that stuff. So cool. I'd rather use this one. Cabin. But this one doesn't have some things. No, maybe they do. I don't remember. I've got all the names. So yeah, something weird happened with the other one. I don't know where I got it. Maybe they already selected out pieces of it. They got rid of the men. But this one's better. Let's read in this one. I'd rather do stuff with this one then. I'll call it Titanic.csv, and I'll put it in ours, and I'll give that to you in just a second. All right. I'd rather use this one. Let's make sure it has all the same columns, though. Where was I? I think it does. Age. Yeah. Ticket, fare. We don't have cabin. Yeah, whoever added cabin messed something up. I guess that's what happened. Weird. All right. But all right, we have this other one as well. Let's read it in. I'll mess with this after class. Okay, there's that one. I'd like to put it in a place where you can have it too. Which could be, oops, on my desktop. This one, this one, this one. I'll put it right there, and I'll replace it. And then if I do that, then we don't get cabin anymore, which is fine. It's a small price to pay. All right. So now, okay, if I do this, I click on it, survived, and some of them were male, right? Yeah, there's one, at least one. Now we know. So, okay, let's redo this. So I have to read in the file again. Let's rerun everything we did, actually. There's that one. Let's get, if that still works. That one still works. Did the values change? A little bit. So there were more people in this one. That's good to know. Like the survivors were, they range to be usually a bit younger, which I think makes sense to me. Like they're going to save the children more than the older people. And most of these other values shouldn't change too much. The fares changed a little bit. Okay. Interesting. Still the amount. And now finally we can answer this question. And it looks like, as far as we know from this data set, it's like 19% men in total survived. And then more often it was the women that survived, which makes sense given the times and how things worked out back then. But okay, yeah, we fixed the data set by answering that question. So that's not the full original question, right? We were also trying to ask, make sure you guys did attendance too, before I stop that. We want an age range as well. And this is a great thing because I want to show you that you can do multiple wheres. So this is just like, give me the men on the Titanic, right? But that gives you a table. And you could whittle that down further, can't you? It's like, all right, I have that. These are the men. Let's whittle it down further. Where now the age range of those men is, like, age values are, I think it's between, right? We are up here. Do we want, yeah, let's do between or equal to. There's also between that it's like strictly not those. Between or equal to has, like, it contains both sides. So like less than or equal to or greater than or equal to. Let's do between or equal to. So where the age values are between or equal to, you can press tab and it'll like autocomplete a little bit for you. Let's do 18 to 32. That's what we thought about. Cool. And so now this is the men who are within that age range. Does that make sense? How you can do multiple wheres at once to whittle it down. And then now, all right, how many? If we can have a percentage and we can also count how many. That's a great thing. So to get how many, this is a table. Every row is a person who either survived or didn't survive. We can get the survivors now. Get the men, right? Get the men, get the fact that they were within this age range. Let's get just the survivors out of that age range. So dot where again? Where the survived value was exactly 1, right? So these are all the male survivors who are within that age range. You could have done these in any order, by the way. It doesn't matter. But does this make sense now? We can count, right? Every row is a person I care about counting now. And so one last time I use the dot for it's num rows, right? Give me the num rows. Apparently there were 39 men between that age range who survived. Does that make sense? This very long line? So that's cool to think about. Like, you can just like select out the things I care about one at a time, start crossing out things, leaving only the things that I care about left. And we do the same for the female ones. And it looks like there's a decent amount more within this age range. There are 83 women who survived. And now we know. Cool. Any questions about how I answered this question? Because this was a long one, and it's a great example of the things you might need to do. Like, all right, circle the ones I care about, circle inner pieces of that I also care about. I only want these, only want these pieces of that, only want these pieces of that. And I want to count the number of rows. That's the number of results in that final table. Cool. Yeah. Any questions about any of that before we go to one last data set? I want you to take a look at, and then I want to show you one thing that will kind of like lead into next time. So here are some of my questions. We kind of answered a few of them. I have made a data set from Wikipedia. There's like a website that you can go to, but I've taken up to the current year, at least, the max and min temperatures over time in Fresno. So that will be in our data folder. So back in the code from class, it's a little long. You can use the tab to like figure it out better, but it's going to be, oh wait, let me quickly, on my end, it looks a little bit off, I think. So I need to do this. Aha. It's this one. And so what this data set is called max min temperatures Fresno up to 2025, at least whenever during the summer when I compiled all this. So we have five columns. We got the date, and we have the highest high in Fahrenheit for that day, apparently January 1st. The maximum high that there has ever been was, like, the hottest it's ever been on January 1st in Fresno since they started taking records was 69 degrees, and it was 1998 when that occurred. And then you also have the lowest low. Like, how cold did it get on January 1st ever since we started taking records? Apparently it was 21 degrees, so below freezing, impressive, back in 1976. That was a very cold year, it looks like, because that was there in a few different places. In 1948 was apparently a very hot winter. Cool. So yeah, this is an interesting data set because it's a little close to home finally, and I'd like you to play around with that for a few minutes, and you can do the same game of like ask some questions and try to answer them. But I don't think we have a ton of time left. I'll let you try them yourself after we break as well. But if you're on the Written Nice page, I'll clear it out if you want to refresh that page one last time. I want you to do everything we've already been doing with all the other data sets, please. So like come up with some ideas, read in that file as a table, stare at it for a second, ask some questions to like discover some ideas that you're wondering about. Try to get those answers, and I can help. All right, so I'll give you a few minutes to try that, and I want to show you something weird after that I won't test you on. It's just cool. Yeah, come up with some ideas, try them out, and then we'll come back. And the name of this file was max min something something. Max min temperatures, blah, blah, blah. That one. I didn't write down things that I want to know. What do I want to know? I guess like, what was the highest high of all time of any day, and what day was it? Maybe that's a question we could ask, right? Same with lowest low. How many days was it above 100? For the highest high. How many days was it below 32, below freezing? For the lowest low? Stuff like that. So you try. Let me know if you have any questions that come up as you're trying things. Good timing. So while you're thinking of things and trying out things, feel free to keep going. I just want to show you something really weird, I think. But maybe we'll do at least one of these, all right? How often did 2025 have the highest height? That's a great question. So this is technically incomplete data because 2025 is not over. I got this and I made this over the summer. So maybe like May or June was when I got this data. So it doesn't have perfectly updated things if there were hot days or cold days. And I think it was kind of like a midsummer, right? So it wasn't that really, it wasn't very hot this summer. So maybe this is still pretty accurate. But yeah, let's see. Let's answer some of these. Average of January's lowest lows. Yeah, let's look for some years. How often? I think I like this question. I think that will be a more interesting one to ask and have it be educational. So let me show that one to you. And then let's do that one, and then I'll show you a weird thing that I want to show you and let you try the rest. So let's see. How do I want to do this? I want to read in the table, right? I want to say table.read table, and it's my data folder. It's in the max min temperatures, blah, blah, blah. And I'll call that temps. So it looks like that. Interesting. And let's see. I would like to look at January, and this is a little weird. I could have split the date in a different way. I could have said I could have a month column and a day column, but I did not. I had this. And so now the question is, how do I extract only the January stuff? Which of these, because it's going to be a dot where, like dot where it's January. Which of these do you think we can use to extract January? Because it looks like 01 slash 01, 01 slash 02, 01 slash 03, it's like that. That's what we need. What's that?
Is the 01 dash?
Yeah, this whole thing, this 01 slash stuff, this will be interpreted as a string. So if we look at, where do I want to be? Here. If we get the column for date, for the date column, you see all the quotes there. So quote means it's a string. So it's not interpreting it as number data. So that kind of rules out a lot of these dot where conditions because most of these have to do with number data. Equal still works for strings, but we want a bunch of different days, so we can't just use equal to, unless we want to pick out January 1st, January 2nd, like doing it ourselves, but that would be tedious. I think, well, our only other option is this one, right? Containing. That one would work on string. There's also not containing. What could I ask? Containing what? What would pick out January? Yeah, so it can't just be 01 because that would pick out the first day of any other month too, right? But 01 slash, that's January, yeah? And that's why I had to put a 0 here as well, because like it could have picked out November if I didn't put a 01. I just did 1 slash. So 01 slash, and that had to be stored like that to make it work. But that'll give us January. All right. Temps dot where the date column values are containing 01 slash, because that is January. Oops, what have I done wrong? Another percent sign, or another parentheses. So there's my January. Perfect. There's 31 days max in January. Oh, what do we want to do to it? What's the average of the lowest lows? Okay. So there is January, and let's get their lowest lows. Let's get the column for lowest low so that I can do math on it. Usually you want to select the column that you care about, lowest low, because then that's an array and you can do math on it. And these are all rounded to the nearest whole Fahrenheit, so maybe we could have found more precise data somewhere. We say dot mean, and apparently it's 22, so like 10 degrees Fahrenheit at least below freezing. Those were cold years, man. Cold Januaries. Lots of frost warnings. Well, cool. That's a great question. So I think all of these are great questions, but we are running a little bit out of time. And so what I want to do at the very end, just to show you something kind of dumb. I'm not going to test you on anything I'm about to show you, but like I think you can imagine, I said the word a lot, that it would be really nice if we could make a graph right now for a lot of different things. That would show our answers in a much better way. That would make it very, very clear to see something that we maybe can't see with just numbers. And so, like, let me show you the best that we can do right now. It's kind of funny. I'm not going to test you on this. All right? It's just dumb and cool, though. So here's what we can do. All right? It's very weird. So I want to do actual more fancy array things. Again, I'm not going to test you on this. So I want the entire NumPy library. Import NumPy as NP is what we do. So there's that. And this plus a cool thing with strings will make it work for us. So like if you have a string, like, I don't know, hi, you can multiply a string in Python and it will just repeat it, which is kind of cool. So with that in mind, I can make, based on the value of a number here, I can make a longer string or a shorter string. And that kind of looks like a graph sideways. So let me show that too. Let's graph, I don't know, like the highest, let's do the highest highs. All right, let's make some sort of graph for those in order of increasing date. So let's get temps, that's the temps table. Let's extract the highest high. So give me the column for highest high of every day. This will get a little weird looking. So there's all the numbers, very hot in the summer, right? And then what I can do is use these numbers to multiply by, essentially. Let me whittle them down a little bit smaller. So like I want to like use these values as like a width of a graph. Because like if I did this, let's say it was 70 or something, then I could say like a number sign times 70 or something. And then like that's a row of a graph, right? That's sideways now. But, like I can make a little bar chart. Have you heard of those? It's like maybe this is too many because like once it gets to 100, it's going to go off the screen. So let's whittle it down. Let's like divide by something. Let's take all these and like divide by 3, and that's how wide this is all going to be. Okay. So these will be the widths of my bars on my graph that I'm about to draw in text-based form. So widths equals this. You cannot multiply by a fraction. Characters don't work like that. So we have to round, and the way that you do that is you say np.round. Again, I'm not going to test you on this. Eventually you'll learn some of these yourself, but np.round all those, please. And these are widths. Let me print them out. Widths. So now they're rounded, but they're still floats, and you still can't use floats when you multiply characters. It's still unhappy, so you have to turn the floats into ints, and the way you do that for an array, again, I had to look this up. I'm not going to test you on this at all. It's like as type int, and then it makes them ints after asking that. But that will give us like a number for every highest high that kind of corresponds to, I divided by 3, so it's still gonna, like, it'll fit on the screen. But now I can take, this is kind of silly, I can take a number sign essentially, or whatever I want to use to draw my graph, like a star or something, and I can multiply that character by all these numbers, and that will turn into a sideways graph. All right, those will be the bars of my graph. So it'll be like bars. I'll set that to something in a second. It's np.char for character stuff. I want to multiply the values of an array by I can say widths by this. All right, I want to multiply this character by all the values in the widths array, because that's these. And that will give me this. Look at it. So they're longer or shorter based on what we see there. Does that make sense? That's so silly. And it doesn't really, it's not full yet because like it's wrapping around itself. We can't really see. But this is now as many entries in this array as there are dates, and I can put it back in now into a new column. So that's what I can do. So I can say, these are my bars. Again, I'm not going to test you on this. This is as good as we can do for graphing right now. I've called that bars. And so I can take Fresno, or not, what do I call this? Temps. I can take my Fresno temps, and I can select out let's do date and highest high, because that's all I'm using here for those bars. And then I'm going to attach a column with column highest high graph, and that will hold my bars. Well, look at them. And it is a little bit backwards. I don't know how to justify it in the other direction, so it's going to look a little weird. And you say dot show to show every single thing there. And if I scroll through it slowly, you can see how it gets a little bit bigger as we get towards summer. Whee! It's still spring, and then it gets disgustingly hot, and then it starts cooling off eventually once we get into what, past August, past September, down into October, then it goes back to being cold again. But that's about as good as we can do right now with graphs, but there's so much more that will make it better and pretty and colorful, and that will be the topics for next time. All right, I'm not going to test you on this. I just thought it was kind of cool because like that's probably as good as we can do right now with our current knowledge of Python, but that's why we're going to learn more next time. So yeah, I think that's all that I wanted to say. Please keep playing around with these data sets. I think it's fun. I tried to find cool ones and try to answer these questions, and I can help you. But I think that is officially all that I wanted to say and record for the day. Just some practice with tables because they are important. They're going to be the backbone of every other thing that we do in this class, more or less. So it's good to get them down early. Yeah. Are there any last questions that we have before I stop the recording? All right. Where is that? Here it is.